Hi guys, my name is Gentry Fitch.
And I'm Monica Alden, and this is Coding for 36.
Today we're talking about calculator tips. Keep in mind this test is 60 minutes long and 60 multiple choice questions. Although none of the questions actually require a calculator, using one can
help cut the time needed per question and reduce the amount of careless mistakes.
This playlist consists of the graphing capabilities, multiple ways to solve a system of equations, using the store function, the math button, trig, and the mode button.
Alright, let's start with matrices. Basically, matrices are just a way of organizing data. They can be added, subtracted, multiplied together, and used to solve systems of equations. Luckily, the TI-84 can do most of the work for you. For example, if you had a problem like this. The first step is to enter each matrix into your calculator. So we're going to hit the matrix button. It's second, and the x to the negative 1 right here, matrix. Then we have to scroll over to the edit and select matrix A. We have to adjust our dimensions, so this one's a 2 by 2, so 2 inner, 2 inner, and then we actually have to enter the matrix. So this one is a 4, negative 2, 3, negative 6, so we're going to enter that, 4, negative 2, 3, enter, 6, enter. Alright, we have that one done. We're going to go back to the matrix sort of home screen, second matrix again, scroll over to edit, and this time select matrix B. This matrix is a 2 by 1, so we're going to do that. That means 2 rows, 1 column. This one is just 0, 2, so we're going to do 0, 2. Got that. So now we have to go back to our main screen. So we're going to hit second matrix again. This time don't go over to edit, just select matrix A. Then we're multiplying, so times second matrix. This time get matrix B. And then we're going to hit enter, and we get negative 412. That's answer choice F, so we're done.
Graphs are awesome to use for the ACT. They show you exactly how a function acts and looks. From this we can find solutions, roots, x-intercepts, y-intercepts, maxes, mins, and solving a system of equations. The ACT will mainly ask for solutions, roots, x-intercepts, and x-intercepts of a function, which are all the same thing, mind you. These results from factoring functions. For example, consider this function x squared plus 6x plus 8 equals f of x. If we were to factor, we probably would get, well, first of all, we have to find the factors of 8 that will give us 6. So we have 4 and 2. X plus 4 quantity x plus 2 equals 0. And these are all the solutions, function, or x-intercepts, roots, or whatever, of the equation x squared plus 6x plus 8 equals 0. So we have x equals negative 4, and keep in mind that they're opposites. So x equals negative 4 and x equals negative 2. Now, using this factoring, we can go back and cut back to our calculator and see if our factoring was correct. Okay, so now we're going to graph x squared plus 6x plus 8. So to do this, we're just going to go y equals and put it in the y1 function. So we have x squared plus 6x plus 8. And just go to graph, and it's going to graph it. Pretty obviously, we can see that the zeros are negative 4 and 2, but just to double check, we're going to do second trace, this button trace right here, enter, and then go to 0, 2. And now we're just going to follow the on-screen instructions. So we have left bound of this first value, left bound, so enter, and you have a right bound of this value, so enter from here, and enter again. And we see that one of our zeros for sure is x equals negative 4. Let's check the second one. So go back to second trace rather, 2 for 0, and do the left bound of this 0 here, which is going to be close to this, and then do the right bound of this 0, enter, enter, and we have negative 2. So knowing this, it basically proves that our factoring was correct and that it gives us the zeros. So sometimes on the ACT, it might ask, it will for sure ask specifically for the zeros, but sometimes it might ask for a really nasty function zeros, which would more than likely take over a minute to do by hand, which is why we use a calculator to find our zeros. What's so handy, and it also shows you what it looks like for other questions. So we're going to do a really nasty function real quick. All right, now consider this function. We have 13x squared minus 72x plus 39. Many of you may know the slide and divide, I guess, method of factoring, or you can complete the square. But that, again, we are on a time test, so we have to get done with things fast as possible. So if the ACT gives you this function and it wants you to find the zeros, solutions, roots, x-intercepts, whatever, we are going to graph that. And so to graph that, we're going to cut to the calculator. Okay, so we have the function 13x squared minus 72x plus 39. And again, like I said before, it is going to be very difficult to factor. So from the previous video, we had the x squared plus 6x plus 8 to find their zeros. So now we're going to do the exact same thing with just a different function. So we're going to plug the function in, 13x squared minus 72x plus 39. And again, there are ways to do this by hand. Actually, the easiest probably would be to use the quadratic formula, which we'll probably get to eventually, but we're going to do it by the calculator first. So anyway, so put it in y1 and graph it. Pretty easy to see that the zeros of this function are going to be really difficult to find. So what we can do, if this was to be asked on the ACT, is again, we just quickly graph it. And so we go to second trace, or whatever, 0, and again, use the left bound. So let's see where I am. Find a left bound point, which is going to be actually, I don't know why the calculator is doing this, but it's putting it way above graph. But we know it's left bound. So hit enter, and then we see the cursor down here, which is right bound of this 0. Hit enter, enter again, and we have a function, a 0 at 0.6085274. I'm going to mark that down. It is at x equals 0.6085274. Okay, and then we'll do it again with the other 0. So we'll go to go to graph, second calc, 0, and now we're going to do it of this right-hand point. So put it here. This is left bound of that right-hand point, enter. Left bound of this right-hand point, enter. Enter again, and we have 4.9299341. Alright, so these are for sure our x-intercepts because the calculator gave it to us. So long that we put it in correctly, they will be correct. But let's go back and check with the quadratic formula. So we're back with this function, 13x squared minus 72x plus 39 equals 0. And through the graph, we found that one of the zeros is 0.6085274, and the other is 4.9295341. And so just to check to prove that this graph is right, we're going to use a quadratic formula, which was used by many mathematicians long ago before calculators even existed to find zeros of a function this nasty. So keep in mind the quadratic formula is as follows. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And this 13 here is your a, this negative 72, keep in mind it's negative, is your b, and this positive 39 here is your c. So we're just going to fill in the numbers and get our answer. So we have 72 plus or minus negative 72 squared minus 4 times 13 times 39 all over 2 times 13. And I just went ahead and used my calculator on this to find out these numerical values. So we have 72 plus or minus the square root of 3,156 all over 26. And so to split it up into plus and the minus for our two x's, we have 72 plus the square root of 3156 all over 26 is one of them, and 72 minus the square root of 3156 all over 26 is the other. And once again, using the calculator just for arithmetic's sake, we get 4.929934139, which is the exact same as that, and 0.6085274 for the other x for this. So using a long well-known function to find these zeros, we are correct, and the calculator is correct, and all is well with the world.